the final part. As you can see, I have all the switches attached to this top cover. All the I installed these buttons the same way I installed this one, exactly the same way. I glue the Kailh or Kailh's swappable sockets onto the bottom, and then I use hot glue to prevent these cables from breaking off from the swappable socket. And this is gonna be installed on the sensor board with the other half of the connector directly into the board. So this whole thing can be pulled off by removing this connector, and then remove your whole cover. I might have to remove the whole cover from time to time just to clean the inside of the trap ball and clean the ball itself. Remove the ball and clean the ball. But that's it. I'll show you the housing where this thing is going. This housing just finished 3D printing today. I left the 3D printing running all night to finish this this housing. I have the 3 BTUs working on this, installed on this unit already. As I told you, I designed the whole thing. And this ball moves very nice. This is a phenolic ball. It's 3.5 inches in diameter. It's a huge ball. And it moves, just moves nice. It keeps going on this BTUs. By comparison with the floppy bolt and caps with the trap ball, this is the difference in size. I think this is like 1 3/4, around 1 3/4 or 1 3/8, 7/8. This is a 3.5 inches phenolic. This is plastic. It's very light. I believe this is plastic. I don't know. I'm not sure. But this is phenolic resin. It's the same stuff that you find in the pool balls. It's heavy. This is 1.6 1 ounce, 1 pound and 6 ounces in weight. That's why it moves very nice on these ball transfer units. So this is the housing, and this is the cover. Just gotta make sure that you don't pinch the cables with the side of the housing, and there's some weight that it has to be installed so you don't pinch the cables. Make sure that the cables are free, and then just install the 3 screws. These are 632 screws, stainless steel screws. This is just to hold the cover. Just tight enough to hold the cover. It doesn't have to be too tight. And that's it. This trackball is almost ready. As you can see, the BTUs are really nice. The ball moves by only moving the housing up and down, or side to side. And this trackball only needs the I need to 3D print the button where I hold the sensor in the board to read the surface of the ball, and this unit is ready to be installed. With these heavier balls, the 3.5 inches balls or bigger, it's better to use BTUs instead of the ball bearings, because the weight of the ball is too much. I believe it's too much. With ball bearings, it's gonna be tiresome for your hand and your fingers to move the ball all day. I do a lot of CAD and a lot of CAM, and I'm using the one with the my trackball, the one on my videos. I'm using the one for CAD and CAM, and it's very nice. But I'm using ball bearings on that one. I'm using the skateboard bearings on that trackball, three skateboard bearings, and it's very nice. But the ball is heavy. It's a 3 inches phenolic ball, and after a few hours, it gets kind of heavy. You can feel the weight on your fingers. But with BTUs, they're easy to move. These are unidirectional. They almost have no friction. You just push it any direction. It just goes. It has almost no restriction. So it's easy to move the cursor from. It's easy to move it fast from one end to the other end, or up and down. But when you need to open a window or close a window or look for some menus or options, your fingers have to work more to break the momentum of the ball, because the BTUs, they have no restriction and no friction, almost no friction. So your fingers have to do most of the work to move and to break the ball. It feels really nice, but I feel your fingers have to work more with these BTUs than with ball bearings. With ball bearings, they kind of because they are position 320 degrees each, like in a triangle, so they kind of cancel each other when you move the ball with ball bearings. they kind of cancel each other with the direction you move in the trackball. It's not as free as these ball transfer units, the BTUs. They use steel balls resting on top of smaller steel balls, tiny steel balls. So there's almost no friction. It's very easy to move the ball, even if the ball is heavy. This ball is very heavy, but it's very. It feels very like natural to move it. Okay, I think this is gonna be the end. This is gonna be the end of this video. I still need to order the the sensor board for this unit. It's not finished. I need to finish the bottom. I need to do 3D print. I need to design it because I have the old design for the 3-inch 3-inch ball, and this housing is bigger 3/8 all around. The other one and the other housing on the 3-inch track ball is 5 inches and 1/4. This housing is 6 inches square. So I need to adapt the other plate, the other housing for the PC board and the sensor board. I need to redesign it and adapt it to this bigger housing, and I need to order the board and the sensors, and 3D print the housing to install the board and the sensor onto this onto the other housing, and then I have to install the bottom to this unit, and it be ready to be installed. This is not a wireless trackball. This is a wired trackball. They embedded onto the top of the desk, so they don't need to be moved, but they do need to be wired to the computer. This is just like a regular mouse. Your left click, your right click. I'm gonna swap the cables. This is gonna be the middle click. This is the scroll button, and this is back and forth. You can go back one screen or forward one screen, but in my case I mostly use left click, right click, and I barely use the middle button or the scroll button. I mainly use for designing on CAD. I'm most of the time, 80% of the time, I use only the left click and right click. And if I want to scroll on the screen or go one page to another, I can use those two, or use push this button, and then to me I'm used to working this way, so I'm always, when I'm scrolling, I'm always pressing the left click and moving the ball up and down. It just becomes a natural reflex when you're scrolling up and down, pushing this button and then moving the ball. Just becomes second nature. It's very easy. So this is gonna be the end of this video. I just wanted to show you how I design and 3D printed and install these mechanical buttons. And if you like the video, leave me a comment, subscribe if you want, and I'll see you soon. I'll see you soon when I have the I'll make another video, a follow up on this video when I have the board and the and 3D print this bottom housing. And I'll see you next one. Thank you for watching.